Hi, in this video, I'm gonna introduce you guys the different types of forces. Forces, is that a vector or scalar? Force is a vector quantity because if you were to, force is either push or pull. And if you were to push to east or north, it makes a different result. So force is a vector quantity. And I'm going to introduce you guys to different types of forces. Let me share the screen. This screen is the best one to share. Okay, went in sideways. Okay, sideways now. Okay, so forces. Force is either push or pull. And unit, do you remember the unit for the force? Is in Newton. And it's a vector quantity. How do we measure the vectors? Maybe we'll come back here. How do we measure the forces? Here, this is a spring scale. You have it in a, you can go to the grocery store and you have something similar too, right? Because the weight is, it's not focused so good. I hope you see the unit here. That says, here, this side is a Newton, the other side is a gram. If I put my hand here, you see better, right? So then, how much I'm pulling? This is a spring inside here. You see that this is a spring. So if I pull it, how much it's pushing, it can measure how much Newton it is. So let's say I'm gonna push this much. It's about 2.5 Newton, 5 Newton, 7.5 Newton. So the stronger I pull, the bigger it measures, right? You can see it. So using this kind of a device, how much you pull, let's see here. It's hard to see. How much you pull, and you can see, you can measure the value. So I'm applying 5 Newton. This is 5 Newton. 5 Newton. All right, 10 Newton, 10 Newton. So the unit of force is in Newton. And the direction is which way it's pulling, or it's being pulled or pushed. So it's a vector quantity, right? So the magnitude is how much Newton, 5 Newton, 10 Newton, that's the magnitude. And since it's a vector, you gotta show the direction. The direction, you show it by the arrow. So most of the forces that we're familiar, so I'm gonna introduce the forces that we're gonna use in the class. So that's the definition of a force. There is, let's start from contact force. Contact force. One of the contact force. Let's start from non-contact force. Let's see, how can I erase it? Let's start from non-contact force. And this kind of a force is also called field force. Field force. So what it means is that it doesn't have to be in contact with the agent to have that kind of a force. The biggest you are most familiar with that's non-contact force is the gravitational force. Gravitational force is when I let go the pen here, right? It falls. It's been pulled to the ground, right? So it's gonna fall. It's not in contact with the ground or anything. As soon as I let go, there is a force that it's there. That's why it's gonna start dropping. And it's gonna start dropping faster and faster and faster. There's a force that keep pulling. That's gonna go faster and faster and faster. So there is a force applied. And there is a force because I'm not pushing, I'm just letting it go, right? I don't push it, shove it down. I just let go and gravitational force is pulling it down. So this gravitational force is called non-contact force, or you can also say it's a field force, gravitational field force. Typically, I use a symbol for gravitational force like this, Fg, force of gravity. So let's say you have an object, right? You always write a simple object like a circle, and then in the center, because force is not just only the magnitude. So gravitational force magnitude depends on mass, the inertia, and the gravitational acceleration that we're going to talk about. So the bigger the mass, bigger the gravitational force. So that's the magnitude. But gravitational force, the direction of a gravitational force is always vertically downward. That's the direction of a gravitational force. Always vertically downward. So let's say there is a ball that's rolling on a flat horizontal surface. You're gonna say, can you draw the gravitational force arrow? What would be the direction of a gravitational force arrow? Still gonna be, it's still gonna be vertically downward. All right, so gravitational force is always vertically downward, and that's called a non-contact force. Another example of non-contact force that's not our field force is the electrostatic force. That's also field force, and non-contact force. Magnetic force is also non-contact force. And there is other kind of forces that's called in a category of, in a category of contact force. So this is the non-contact force. I'm just going to write it in a different page. And now I'm going to talk about contact force. Contact force. So among the contact force, there is something that's called support force. Or I also call it normal force. And I use typically I use the N to mention that's a support force. All right. This is in contact whenever it's on a surface. So when the object, any mass is on the surface when it touches. And the surface means you're in contact with another something, right? Material. Then all the materials are made of molecules and atoms, and they're bounded tightly together. And this, how they're binded, is almost like they're connected with a spring. So when the two objects are in contact with each other, you push it slightly or you're in contact. So you almost bend these springs a little bit. So these, on the surface of these molecules, they will be compressed. Yellow is too hard to see. It's gonna be compressed. Then, because it's compressed, they're gonna act. If it's compressed, the spring is compressed, they wanna act, there's a restoring force to go upward in an opposite direction, and that's called the normal force. So when you have an object that's in contact to the surface, right? In contact with the surface here, then there is a normal force applied that's always perpendicular to the surface. Perpendicular to the surface. That's why I say normal force, because it's normal to the surface. How about a case like this example? So can you write the normal force? If this object is on that inclined angle, right? It has some kind of an angle. Draw the normal force. What would be the direction of normal force? Direction should be perpendicular to the surface. Okay. So I'm going to tell you the answer. It's going to be perpendicular to the surface. So it's going to be something like this. That's going to be the direction of normal force. So that's the support force, normal force. Is always perpendicular to surface, and it's in a category of a contact force. Another another forces that we use is, there's a contact force, let's say friction force. Friction force, I kind of write like this, is to oppose the motion or to oppose the exerted force. That's what the friction force is. And it happens parallel to the surface now. It's parallel to the surface in this case. So let's say you have an object here, and there's a push force. It's motion, direction of motion. So it's moving to the right. Then the friction force is applied on the surface, parallel to the surface, but it's going to be pointing in an opposite direction to the motion. That's going to be the friction force. So direction is parallel to the surface. So again, it's here I'm talking about the solid surface. Friction force that happens in a solid, in contact with the solid surface. when we talk about air drag force, that's also a friction force to oppose the motion and oppose the exerted force, but it's a little different. But it's still a contact force because you're in contact with the fluid, like air molecules. But anyhow, it's always, if we're talking about if it's in contact with the solid surface, the friction force applies parallel to the surface and the direction, opposite direction. Of either exerted force or the motion, direction of motion, right? You could sometimes have a case like this that, oops, somebody's talking. You could be having pushing, 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 but it's not moving. So you have a force that's a push force. This can be considered as a normal force, by the way. The push force is pushing it to the right, then still, but even if it's not in motion, that means if this object is not in motion, it's because there's a friction force that's applied opposite to the push force. That's why it's not moving. So this is going to be the exerted force in this case. The push force is considered to be exerted force. Friction force applies opposite to the motion or opposite to the exerted force. And again, parallel to the surface. So that's the friction force. Another force is a tension force. Tension force, I typically use the label T. It happens along the string or the rope and things. Let me see. So let's see here. I have a cord, and along the cord, when it's just taut like this, not taut, then there's no tension force. But if I start pulling and pulling and pulling and pulling, there's going to be a tension force along this cable, right? And then I can pull harder and harder and harder. Let's put this one here. Right? And then let's say if I'm going to pull it, I have to put a rope, I have to connect it. Okay, so I pull it harder and harder and harder and harder. And you see there's a bigger and bigger tension force applied, like this maybe. You can see more and more tension force, more and more and more tension force. So the tension force is the force that applies in the rope, along the rope, or the string or the cable. And that's called the tension force. And of course, it's a contact force because it's in it, right? So this happens along the rope. So you could have a rope like this. And there's going to be a tension force. Tension force that's in the rope. We'll talk a little more about tension force once we do the Newton's third law. So there's a typical contact force that we discuss in a class. Is the tension force, friction force, right? And the normal force, support force. And the typical non-contact force, field forces, is gravitational force. I want you to know, you will need to know the magnitude, how to find the magnitude of the force, all these forces. It depends on how the case is, right? But here, I want you to know the direction of the force. For gravitational force, it's always vertically downward. Contact force is, support force or normal force is always perpendicular to the surface. And it's not moving so good, huh? Friction force is to oppose the motion. Oh, sorry, super slow. No, it's not, sorry. Stopped acting. All right, good. No, the screen in here is different. Okay, so friction force is opposing the motion or exertive force, and it's along the parallel to the surface. And what was the other force that we did? Friction force, normal force, and tension force, right? Tension force is along the string, along the rope cable. So those are the typical contact forces that we deal with, and I would categorize with a non-contact force and a contact force. Okay, so that's it for this lecture. If I stop sharing, maybe it gets better. Let's get back just one more time. Yeah, okay. So the support force, friction force applies to oppose the motion or oppose the exertive force parallel to the surface, right? And then tension force is along the strip or the rope. So let's say for the example of the tension force, what if I have a rope, two strings that's hanging like this, has a basket with let's say, apple in it. Then draw a direction of tension force on these two strings. Then you have a one tension force on this rope, and along the one rope, it's going to be the tension, same tension force throughout. But you could have another tension force, T2, because it's a different rope. This is not the same rope. So if you have a two different rope, you have another tension force on the second rope. So that's how you can say that these are the two tension force, and it's always along the rope. Friction force, normal force. All right, so that's it for this class. And then I will see you in the discussion.